Okay, so that's going. See how this all works. Okay, so as usual, good people, the first thing is going to be a list of things we're going to cover. So I'll just show you today's homework first of all. Today's homework on Teams. Second of all, what do we got? You'll see coming up. We got a warm up on yesterday's work. So you'll be able to see it. And if you missed the class, you'll get an idea of what's going on. And if you need extra help, then, well, just arrange a time to get caught up. Yeah. There's some new stuff today. Adding and subtracting square roots with one another. A few questions there. And then that's it. Oh, no, that's not it. What we'll do is we'll finish up the week's work. That means all the homework. There might be some questions from the homework, right? Yeah, so we'll take care of that. And then, I should be able to hand it all in by the end of the day and have a nice weekend. Yeah, with only a little bit of math work to do. Not a lot. Okay, the usual question from you guys. Anything? Anything to go over? No. This is good enough? Certainly good enough for Friday, right? Okay. All right. So, yeah, thank you from class. I am recording this, so we are live and broadcasting. First thing, just the homework's might be a little different today. Here it is. That's a Zoom link for everyone to see later on. But what happens is there's level 1 type homework. So that's going to be required for everyone to do. And then some more challenging type questions are available here on Teams as well. And they are printed out, but they're just downstairs. So I'll have to go and get them if someone wants to work on these. And these will count as extra bonus type questions for you. Extra challenging type bits of fun. Yeah. Okay, so so look for that. I like this where, there's sort of 2 levels of questions for those that want to complete the course, and those want to get really ready for their future and such, eh? Practice that way. So I'll probably have these 2 levels often. Okay, so that's the special message about the homework for today. Okay, now we can do. Now that's done. Close this. We'll move this over here. See a couple people online. That's good. Expecting a couple others, so keep my eye there in case there are any struggles with technology. Still might be. I like our beautiful screen there. Look at that. That counts as a struggle. Okay, so what do we do? We'll do that to get rid of it, open it up again, and beautiful. Okay. Here's what we got for our warm-up questions from yesterday. Oh, happy Friday, everyone, especially from the cashier for the good work you're doing. Did you guys take a look at this bridge as well? Yeah? Remarkable, eh? That's what happens. Okay. So, gentlemen, we got this as well. If there's time, I'm going to stick around today to get this done because I've been promising and haven't done it yet. You guys are sounding pretty good. Okay, but today I'm actually going to sit down and do this, which means have them all memorized. A lot of people know the square numbers. A lot of people know the cube numbers, but the primes, not so good. Even myself, I got to think of a couple of pause, right? Shouldn't be a pause. Should know it automatically. So I'm gonna sit and make sure I do this today. Here we go. This is warm up number 1 for you all to work on, to try. Okay, with your brain. You can check with Casio, but use your brain to work this one out. All right. So what'll happen? I'll give you a couple of minutes. You can chat with your buddies about this. Try and remember. Try and figure out the strategy. I'm going to point out though that for mixed radical, okay, it's not like this where it's the inside only. What do you want? A mixed radical has the outside and the inside parts. Okay, so usually if it doesn't say, then write your answer like that. And simplified as well, meaning that as small as possible. Okay, don't leave it big, like a root 12 or something. We know from last day that can go down, right? Root 18, that can go down. Okay, as simple as possible. Okay, so as a rule, answer it like that. Yeah, now questions, comments. Anyone from class? Answer right away. We'll do the usual. I like the initiative. Oh yeah, from Zoom, go ahead.
It's 6 times 4, it's 24. Like, I know.
Yeah,
So
it's
12.
Zoom, it's a little hard to hear you. Can you adjust?
I just want, it's 6 times 4, it's 24. So it's, the answer is 4, and I'm not sure.
That's the right idea, Zoom, is you multiply those. That's one way to do it, is multiply those numbers together. Okay, and then work it out from there. Okay, so you can work through it that way. I'll show the answer here. And there's also a second way to do it, which I will also show.
Okay.
Okay, so yeah, it sounds good. From class, yeah, Parsa, what's the answer you think? Strictly 12? Okay, let's take a look. Let's take a look here and see. Mark, Peter, anything? Good? Yeah, okay. 12 is a thinking there. Lara, Dunya, what do you think? Not yet? No? Okay, not sure? Let's take a look. So we're gonna show 2 ways to do this. Or maybe 3, depending on what you all say. Method 1. For those of you to work this out, Yo-Ya, did you work it out? Yeah, that's right. Yeah, okay. So then how did you do it? What style of answer did you do? Oh, okay. So you multiplied these 2 together? Yeah, that's one way we did. Multiply these 2 numbers together because we're allowed. Put them underneath 1 square root. So this is just, that line there is for teaching, right? What do you get though? Nicely done. You said 144. Beauty. Even looks pretty good. Okay. And then that's one of those numbers, right? It's 12, right? Recognize it from there, right? Okay, that's good. Peter, did you do it this way or a different way? This way? Different way? Okay, so let's admire this for a second. This is beautiful. Looks good. Give it a smiley face. But yeah, I'm thinking of another way that I want you to know. We'll see what Parsa has to say. Method number, oh, did you need it on still? Okay, we'll keep it on there a little bit. Maybe just to explain while copying is going on. How did you figure it out? Finished? Method 2. Parsa, and maybe me, depending on what you say. Just give me a second. This is what we're solving. Equals what? We do know the answer is 12. Mm-hmm. That sounds pretty good. From class, I'm hearing some prime number type things, some squaring type things. Yeah, that sounds good if I followed what you said. Parsa, what did you say? Mm-hmm. 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 Yeah, not bad. That gets, from what I'm hearing, that's kind of what I'm thinking. But I think Dunya, you kind of got there as well. So let's take a. I'll show the prime factor because that's precisely what we did. Um, I think I'm okay actually because I got. It's from what I'm hearing from you. This is the prime factorization. You can help me out while I write it up here. Just for this, I like you guys getting up and moving around actually, but for these warm-ups, we'll just do it here. 24, what does it change to? We could do a quick factor tree. Yeah. 4, 2, 2, 2, right? So then do it better. This is all right in the middle of the page now. Unbelievable. So that's true. So I can continue in here somehow. I'll do over here. That could work. Okay, so our question now becomes the 24 is all those twos. What's that? We do. To save, oh, good. We can put it down there. 6 is going to be what? 2 and 3, 3 and 2. Yeah. I'm going to try and squeeze it in here somehow. So this is similar to what I heard earlier. Some people kept the 6, which is okay. This is going right down to the primes, which is like we did in class. Okay, so for the 24, watch my 2s again, eh? 1, 2, 3 of them. Not like last day. And then 1, 3, true. Times the 2 and 3 like that. 24 is this whole thing. 6 is that whole thing. Okay. So then we had, what happens next? Those two. Those two will go to the outside. Mm-hmm. Yeah. What do we do with these ones? Dunya says time them together. Yeah, that's what I'm going to do. It'll take care, I think, a couple methods at once. This 2 goes out because there's 2 of them. These ones, they don't. They stay on the inside. Stay on the inside, but stay on the inside. Stay on the inside, right? Okay, but what can we do now? What can happen again? Can't circle them there in different spots, but those 2 will go out. Making this one. This 3 and this 3 goes where? Out as well. Left with what? We wrote it as empty the other day. Correct. Yeah, this is more for teaching and reminding you. Empty there. Final answer, 12, as we know from before. Okay. Okay, so that looks pretty good. So that's one way. I'm going to do the third way. Keep this. I'm going to keep the 6 in there because that's useful. So watch this. Larry, you okay? You look scared. You look scared. Are you okay? That's okay? I don't know. It's the mask. I'm trying to figure out eyeballs. I don't really know. Okay. What was the question again? 24 and 6, right? Okay. You guys are gonna have this memorized. So for this, all I'm gonna do is I'm gonna keep root 6 just because. Okay, so the first 24 becomes 4 root 6 times root 6 like that. Splitting up the first one because we are allowed and we keep those 2 root 6s together. Beautiful. What's the square root of 4? That's a 2. And then honestly, just for teaching bits, keep that line there. But to finish, almost finished now. What's the square root of 6 times the square root of 6? Yeah, this thing here. That's the square root of 36, right? Nice. Square root of 6, square root of 36 is 6. And so we get a final answer of 12, as we've now seen a few times, right? Okay. Everyone all comfortable with that? Looks good. Yeah. Okay, perfect. So that was a one warm-up question. Let's take a look at the next one. Next one here is some dividing. Certainly different ways to do this one. Okay, so let's take a look. I'll give you guys a second to work it out, to try it. $24 over what? Over 15. Mm-hmm. Adil, how are you doing over there online?
I'm just thinking.
Okay. I'm just going to check Teams one more time for those other people, just in case. So if we get disconnected, I'll reconnect. It's a lot of work for my old ancient computer to do. That. Yeah, okay. We'll keep that closed. And everything's okay there. Okay. What do we got there? Is that a Christmas card? Is that a card? Oh, it's a limit. I saw the sign. I'm like, oh, that's nice. Friday afternoon card. Okay, good people. How do we do this? Simplify it first. Okay, so what does that mean? In math, there's a lot of different ways to simplify. So which one are you talking about? Oh, okay. Okay, so just hang on, Peter. What I'm gonna do is sort of paraphrase along the way. So you can keep going. So all underneath one root. So it's gonna look like this. Big, tall square root. getting both of those on the inside. Perfect. Back to you. That's it. Just dividing. 3 goes into both with the trick from last day, if you don't remember, right? 24 does divide by 3, 15 by 3. What do we get? 8 over. Not bad. Okay. Who got this so far? Clearly you guys did. Yo, yeah, you got something close? Got this? Dunya? Yeah? Okay, now, not bad. For dividing, we actually have to take this a little bit further. I don't think I mentioned this yesterday, just class went on long enough, I figured. You guys started the homework. So this part might be new. Okay, so if you got up to here, it's good so far. But check this out. This is what the good looking final answer will look like. Okay, a big tall square root. Yeah, I don't think so. First thing is to split it up into a top one and a bottom one, okay? That's at a minimum. You'll see something like this in grade, in math class, okay? But officially, there's even one more step to do. And I don't know who said it, and I kind of forget the reason, but on the bottom, you can't have square roots in the denominator, okay? If you punch this in your calculator, you get the right answer. But when I see a square root on the bottom, it's like, no, you got a little bit more to do. One more, 2 more steps. Okay, so here's what those steps are. Okay, what you got to do to get rid of the square root is this little trick here, this fact. You multiply the top and the bottom by the square root that's there. Okay. On the top, we get, on the top, we're going to leave it like this for this particular question, just because I see something that we need to think about. But what I want to focus on is the bottom, the denominator. What's the square root of 5 times the square root of 5? Yeah, 5 times 5, 25, right? Okay. Exactly. So just for here, watch. Square root of 25 is 5. Okay. Nice. We can work on the top a little bit. I want to focus one last thing on the bottom. Okay, look at this. Square root of 5 times the square root of 5. We climb up the mountain. We get a big number. See? Yeah. Someone in class just said, we can just use, and then waved her hand. And it's true. We got a 5 there and a 5 there. They're the same. So we just get a 5 there. Okay, so we can go around the mountain. We can just skip right to there instead of climbing over and getting some big number to work with, okay? That's the little trick, little shortcut there. Okay, and that's the important part for dividing radicals. You need to do this extra step. No more square roots, good times. Okay, the trick again, I see a question and some eyes over there. Whatever square root you see on the bottom, you use that, top and bottom there. Okay, that's what works. Now, for this particular question, yeah, some good people saw something. 5 is finished. Can't really do anything there. But 8, you might recognize, is starting to get big. All right, it's worth another look. Okay, what can this 8 switch up to? It's going to be 2 root 2 for the 8 only. I'm going to put in brackets just to highlight that I'm working on the 8 only there. Right? That's using the last day stuff. Then off to the side, there's still the root 5 there. Okay, can't get rid of it. It's still there. And so that means there's one last step to the question. And yes, I heard the answer. It was good. Good and correct. The 2 stays. The 5 certainly stays after all our, well, if you can see it there. The 2 stays. The 5 stays after all our hard work. But now these 2 things. Yeah, those 2 can multiply together. And they really can't simplify anymore. There's no squares to pull out or anything. That's all that we got. Okay, so the final answer is going to look like this. 2 times the square root of 10 divided by 5. Finished. Okay. Question from class. Go right ahead. Where do we get the, oh, this here? Okay, so this came from the 8. So watch, I'll do this off to the side over here just to remind you. Square root of 8, what is it equal to? Same. Factor tree. That goes underneath. 2, 2, 2. Beep, 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 beep. Sorry, it was off the page. Factor tree. 2 times 2 times 2. 2 2s will pull it out. So this is what now the square root of 8 turns into. Okay. It'll come automatic once you do a few. But if you don't see it, then just like I've shown here, you'll have some little bit of side work to do to get that answer. And this might be a nice way to organize it. What I'm trying to do is have like the main work on like 2/3 of the page, and then have the right-hand side, right third for the extra stuff. So I go here, here, here. Oh, I need to go up to the side, create some side work. Then goes back into the question afterwards. Might help. Yeah. Would you guys like another dividing question for practice, just because of this extra stuff? And what likely came up in the homework? Yeah, let's do one more. And then we'll get into the new stuff for today. And then catch up time. Okay. So this is warm up then. Warm up 3 for dividing. Let's see, what would be a good one worthy of your experience and intellect? Something like this, I believe. I think this one. 27. Oh, let's make the game fair. You got to see the question. Peter, you all right over there? Try this one. Try it in your head. Try it no hands if you can. If it's easy. I say no hands, all I see are hands are waving. That's good. It's okay. It's fun. I haven't done it yet myself. I think it's good for you guys. We'll see. That goes like that. Oh no, it's too easy actually. Outfoxed myself. Okay, we're gonna have to do another one. Sorry? Would you 4/3? Is that what you got? Yo, yeah. What do you think? You're going like, Okay, let's check it out. Clock's ticking. How do you want to do this? Prime factors or just divide them? Prime factors? Two different ways. It's up to you. Or just, what do we call the other one? Just divide. That means put them all in one big, one tall square root. Okay, prime factors by request I heard. So 48, what does that turn into? Still separate. I asked the question, then I didn't listen. Okay, one more time. How many twos? 3, 6, and we can do it in 2 steps. That's okay. 6 and 8. That means for prime factors, 2, 3, just in order, just because. If you wanted to switch it, of course, that's okay. Just like that, right? Indeed. And on the bottom, what do we got? 3, 3, and 3. That's why I missed my threes there. So that's like that. Okay. Now what? Yeah, the top one, sure. Those twos go out, makes that one. Those twos go out, makes that one. Three on the bottom. We'll talk about that. There's a couple of things to do, to be honest. So we'll do it like this, just to finish the top. On the bottom, same thing. I bet. Circling now, just because they're together, right? So we get 3 root 3 like that, right? Okay. Indeed, what happens with the square root of 3 on the top, with the square root of 3 on the bottom? Yeah, they divide out. Cancel it if you want to use that language, but it's not really mathematical. Giving a final answer, Mark, of what did you say? I'll take 4/3. Nice. Yeah, good. So this is true, but yeah, it doesn't show what I want it to do with square root lingering on the bottom. Okay, so one more time. Not 27, but okay, from class, someone is saying there's an easier way to do it than this. Yeah, likely actually. Let's take a look. They're writing on the board, so I'll copy what they're doing on. Oh, did you need to see this? I'll copy it in the notes so it's in the video and all that later on. So in class, yeah, there, you know what? The student in class just sees the groupings all right away. So instead of having the twos all over the place like here, put them together and then took them out all together as well. Certainly that's okay. You see these shortcuts after a while, absolutely you use them. Okay, so what I'm showing you are some safe things that that can always work. Absolutely. Let's see what else. We had 6 and 8, 12. Yeah, that's about it, I think. Do it like that. Okay. So for the last one, this will involve some multiplying there at the end. So 27 was the last warm up. I have 24 over, I think 18. I think so. If it happens again. If it happens again, we're going on. I wonder what this is. You got it? You do? I don't yet. I'm trying to decide what to do. Prime factors, different way. I'm going to do a different way. We know the prime factor method. We've seen it a couple times. So I'm going to show a different way. I'm going to keep the sixes. That's what I'm going to do. Mark, final answer? You got one? No, I know. That lingering square root makes it take a little longer, right? That's okay. Me too. I got a couple tricks. Parsa, what'd you get for final answer? Just 2 over 3? I see. Do I need to make another one? No. No, actually. I think this does what I want. Again? We just had that. Yo, what'd you get? Divided by or over? Over. I think so. Yeah, I think I get something like that. Zoom's. I'm hearing some Zoom noise. What do you got there, Zoom?
8 over 2.
Close, Zoom. I think the over part is correct. I think it's over 3. Let's just check it out to make sure. Okay, let's do this. So we could do prime factors like last time, but I'd like to show you this. And if you want me to do the prime factors, I could do that as well. Remember, we can write this 24 using one way to do it is to write it with a square number. So I see that 4 times 6 is 24, and that 4 is a square number from our list. Yeah? Yeah. 18, same trick, same strategy.
2 over 9.
Not over 9, Zoom, but times by 9. Yeah. Over means dividing, right?
Oh, yeah.
Okay, so that's what we got there, 2 and 9. But yeah, now we can split them up. Split them up. Just like that. Now, what's the square root of 4? 2. What's the square root of 9? 3. Leaving root 2 on the bottom. Just switch the order there. Nothing fancy. We're allowed to do that with multiplying. Okay. Now here on in, we can do two different directions. One is to do the thing that I showed you how to do. And that is get rid of the square root on the bottom. Okay, that method's actually a little bit longer. So it's not the best way to answer this question, but it can show you how to use that method again. Okay, so I'll put here long but useful. Okay, the fast way is look at this, 6 and a 2, right? 3 on the top. Okay, so we could go directly to the final answer, which will be 2 root 3. What's 6 divided by 2 again on the inside? 3, right? Okay, so 2 root 3 over 3, like that is our final answer. Okay, so this part's going to be extra because I want to show that square root stuff. Okay, so watch. Multiplied by what? The square root only. That's what's causing the struggle down there. Oh, there too. Okay, whatever the square root is, top and bottom. Now you multiply them. So on the top, the 2 stays, and we get a 12 on the inside there. See? Long, but it's going to be useful. On the bottom, what do we got? It will be 6, but for teaching purposes, just that there. 2 times 2. They're both under the square roots. Yep, 4 for sure. Okay, yeah. Actually, so here, what we can do, we can get on the bottom, we get 3 times 2. And on the top, remember that square root of 8 that we had from before? Okay, same sort of thing with the 12. I'm going to say it can change to 2 root 3 with some side work. Okay, now then, what happens? The 2's divide out, and we get the same final answer that we got the shorter way, right? Okay, we're gonna leave it there. Show a couple examples and then keep our eye on pie time for Friday. Final answer, this one right here. Same as the one we just did directly, right? Okay, same. Oh, is it off? Oh, I just can't see it. Well, that's even worse, eh? Can't at all. What the heck? Now what do I do? It's this one. Only over there. Actually, someone get the front light. Is that the issue? Yeah, please.
Yeah, I think the light is just like, but your hand this side, but maybe it's work.
I'm gonna have to set up on the other side of the classroom or something. I don't know. Okay, the blinds. Don't want to close the blinds on a beautiful day, but might have to. Would you mind? Maybe this one here. Nah, that's not it. Maybe I can do this. Oh, that one there. That's the one. Okay, everything else will leave open so we get some sun. Not great, but not horrible. Right there. Final answer. Okay. Okay. Let's take a look at the new stuff. Fortunately, because of all you've seen before, there's only a couple things to remember. Quite nice. What do we got? Something like this. Do you guys remember this from, I don't know, last year? Year before? If you have 2 bananas plus 5 bananas, how many bananas do you have? 7, right? So what we see here in the upper left is if you have 2x, 2 x's, and 5 x's, how many x's do you got? 7 x's, right? So I'll officially write it here, and we can check the camera and our lights and everything, but that's for the first one there, okay? Going across, 2x plus 3y, what does that give? No. No. It stays the same. All right. If you have 2 oranges and 3 bananas, what do you got? 2 oranges and 3 bananas. Okay. If you got 2 x's and 3 y's, what do you got? 2 x's and 3 y's. That's it. There's no change. Okay. There is a change here. Right. What about the next one? Going down here with the arrow. 3x minus 7x. Minus 4x, minus 4 bananas. That's right. Someone's taken 4 bananas away. Minus 4 there, right? How about the other ones? That's it. No change. Okay, it stays the same. So when can a change happen? When can you combine terms together? What do you notice? What do you notice about the letters that you see?
Because both XX,
Zoom one more time.
both has a letter X.
Nice. Zoom says both are letter X, and that's right. When the letters are the same, then yes, combine together. When they're different, then no. Just making up yet a different example. Okay, that's 9x, right? Absolutely. When they're different, no. Okay. Now, this is going to apply. The reason I'm showing you this is that this is going to apply to our square roots when we start working with them. Look at this here. When the roots are different, we can't go adding them together. Okay, they're finished. That's like having an X and like having a Y there. We can't do anything. Okay. Okay. Look at here. Example 2. We have a root 2 and the root 18. Are those the same? No, they're different, right? So it looks like X and Y. It looks finished, right? Okay, but here's what's special with these square roots. When the numbers start getting big, you got to do some side work. Okay, look at the root 18. That's pretty big, right? So it's so big. Let's take a look and see. 18, 9, 2, 3, 3. So the square root of 18 is 3, 3, 2. 3 and 2, right? Okay, so let's go back to the question now. See a little bit of side work because it's so big. What do we see? We see This is the official question. 3 root 2 plus 4 root 18. This is now equal to, okay, I'm just going to keep it all lined up. This 3 root 2 comes down, plus 4, but look at this. We now know that root 18 is the same as 3 root 2, right? Okay, so that can go in there. So they looked different. Little extra work, though, shows that they are, in fact, the same. See, we got 3 root 2 here. How do we multiply these together? 4 times 3 only, not 4 times 2. 4 is on the outside, 3 is on the outside. So we get 12 root 2 like that. And so now this is a little different than before, right? Root 2 here, root 2 there. We have the same square roots now. So can we add those together like the bananas? Certainly can. We got 3 over here, 12 over there. How many in total? 15 for the outside. Those add together. And these stay the same. Okay. When we add our bananas together, we didn't get bananas squared, right? Bananas stayed as bananas. X's stay as X. Square roots will stay as square roots like that. Okay, let's check another one. See, same style of question. Just a little bit bigger. The numbers a little bit bigger. To start with, did they look the same? Nope. So you want to stop and go home? Yes, I know you do. It's Friday and it's almost pie time, but that's okay. Let's do some extra work. Let's do some extra steps just to check, okay? So let's check root 12. What the heck is that? Do we know it right away or do we have to? It's starting to be familiar maybe, right? It will be 2 square root is how you say it. Square is something different, but yeah, that's right. So I'm going to keep it all on the line here. So I'll get that square root 12 is 223, which gives 2 square root. Yeah, 2 square root 3. That's good. And the other side? It will be, yeah. It's 3 square root 3. We can check it in the same way. 27, 3, 9, 3, 3. All right. All together. And now out. 3 root 3. Okay. So now this counts as side work, just checking what these values are, right? So we got to go back to the main question now and put these updates, if you want to call them, into the equation and make it work. Geez. Okay. Yeah, I'm going to fight with the light in my camera. You guys can fight with the math. What do we got? So back in the original. Again, just for teaching purposes, I'm going to write the original question down so you can see it all flow, but organize your work better than this, okay? Once you do some of these. 4 and a root 27 like that. It's 3 the root 12 turned into a 2 root 3 like this. Brackets to show it's Friday over here, Hadil. People are crazy.
It's okay.
It's good crazy. That's all right.
Yeah.
What did 27 turn into? 3 root 3. Beautiful. Now, I think that this multiplying might be new, actually, now that I think about it. What do we get? 6 root 3, 6 root 9. I don't know. Yeah. By the way, I'm saying root instead of square root, as I just said, because it is square root all the way through, right? Okay. It's true. Minus 12 root 3 like that. It is. So you got to watch with your integers. This is sometimes people get this stuff wrong. So watch that. But 6 take away 12. A useful way to think about it is going down a flight of the stairs and then down into the basement. Right? So you're going to be down underground by 6 root 3 there is your final answer. Okay. Beautiful. So if you take a look back, we had adding and we had subtracting. Math-wise, they kind of count the same, different than multiplying and dividing, right? Let's see, this is 3. I don't think I have too many of these today because I said it goes back to what we did earlier. Prime factorization to simplify. And all we're doing now is checking to see if our square roots end up being the same or not. If they're the same, we combine. If they're different, then they stay. Oh, look at that. That was it. The last one. Okay, so as I showed you at the start of the class, oh, this is off the screen. As I showed you at the start of the class, there's some required homework there and then some bonus homework there as well. So for Zoom, you can we can finish for today and you can go and take a look at the sheets that are on Teams. I did get your message about checking your earlier work. I haven't done it yet. I'll do it after class today and then message back to you. But otherwise, you are free to go unless you have any questions. No? Okay, then I'm going to stop recording, but I'll keep the headset on in case you have any questions. Stop that there. Okay, perfect.